Okay, I seem to have caught a case of amnesia. Could you refresh my memory? 1. What are derivatives again before we go into the products and quotients that Dr. Stevens discussed today?
The derivative of a function f is a new function of f in which it can be used to find the slope of the tangent line, instantaneous rate of change, and the velocity. But in this case, we are using the derivative to define products and quotients.
How do you find the derivative of products and quotients?
The derivative of a product is the first function times the derivative of the second function, plus the second function times the derivative of the first function. Let's take a look at the formula.
Oh, okay, so the product rule is somewhat similar to the FOIL method of algebra.
Correct. Now that you've seen the formula, I'm going to do an example. As I'm solving the equation, look at where I am placing the prime symbol. Remember to take the derivative of the first and second equation before simplifying the problem. Pay close attention to which symbol, whether addition or subtraction, that you are using. In this case, we are using the addition symbol. Now that we have found the derivative of both equations, we are going to simplify it. This will leave us with our solution of f prime of x. The equation I have is 2x to the third times x squared minus 2. I'm about to solve the problem. I have 2x to the third times x squared minus 2 prime plus x squared minus 2 times 2x to the third prime. Now I am going to take the derivative. I have 2x to the third times 2x plus x squared minus 2 times 6x squared. This leaves me with 4x to the fourth plus 6x to the fourth minus 12x squared. Now I have to combine like terms and this will leave me with the solution of f prime of x. So f prime of x equals 10x to the fourth minus 12x squared.
I think my amnesia is starting to wear off a little. But let me try a practice problem just to make sure I'm cured.
Great idea. Do problem number 13 on page 239 in the textbook to test your comprehension of the subject.
I have f of x equals x squared plus 1 times 2x minus 3. 2. Solve. I'm going to do x squared plus 1 times 2, since I took the derivative of x squared plus 2x times 2x minus 3. Now, I have 2x squared plus 2 plus 4x squared minus 6x. Solving, I end up with 6x squared minus 6x plus 2. Okay, I finished number 13. So tell me, am I cured once and for all?
Wonderful. You followed the steps and showed your work properly. Now it's time for the derivatives of quotients.
Yippee. Is this harder than the derivatives of products?
Not at all. They are at the same level of difficulty, so you will be able to perform just as well on this subject. Don't become discouraged, stay positive.
So, how does this relate to my life?
The derivative of the quotient of two functions is the denominator function times the derivative of the numerator function. Subtract the numerator function times the derivative of the denominator function. Then we must divide by the denominator function squared. Let's look at the quotient formula.
This looks hard, but for some strange reason it seems so simple.
Glad you mentioned that because it's not that complex.
Okay, bring it on, I'm ready. Before we continue, I just have to ask, how does this relate to my life exactly? I'm just curious.
Well, think of something that has recently happened to you or in the news. Whatever you think, I am sure I will be able to tie in the derivatives of products and quotient.
Okay, what about Beyoncé's album, 4, and how it is one of her best solo albums to date? I love Beyoncé. There is no way that products and quotients have anything to do with the music industry.
Perfect example actually. Let's determine how many CDs she has sold over the past 10 months.
Wow, so you can use the derivatives of quotients to analyze CD sales. I think I just might love this stuff. Well, maybe not.
Yes, you can. Math is very fundamental in most aspects of our life, whether we recognize it or not.
All right, I'm ready to do an example, but I don't know if I can do anything on that level.
Staying on page 239 in your textbook, attempt to do problem 44.
I have 3x squared over 2x minus 1. I've placed the denominator as the numerator and multiplied it by the first numerator and subtracted the first numerator times the denominator. I have 3x squared times 2x minus 1 prime minus 3x squared prime times 2x minus 1 over 2x minus 1 squared. So I have 3x squared times 2, and I only have 2 since 1 is a constant and cancels out, equaling 0. Minus 6. X times 2x minus 1 over 2x minus 1. Now I have to square the denominator again.
Yes, always remember to square the denominator of the function. Do not try to simplify the denominator.
Okay. I've placed my prime symbols where they belong, after the denominator multiplied by the numerator and after the numerator multiplied by the denominator.
Good job. Now complete the problem.
I have 6x squared minus 12x squared minus 6x. After multiplying the numerator and combining like terms, I ended up with negative 6x squared minus 6x over 2x minus 1 squared. Is that correct?
Excellent job. I think your condition has worn off and you should be prepared for class on Thursday. When you have time, try to do a few more problems so that you have more practice.
Thank you. I can think clearly now the fog is gone. I think I'll be prepared as well. See you next Monday.